Good morning, students. Today I am going to continue the digital electronic classes. In today's class, we are going to discuss the conversion of number system, the logic gates and the Boolean algebra. In the previous classes, we have discussed about the number system, the basic logic gates, the universal gates and the special gates. In today's class, we are going to discuss the Boolean algebra and logic gates. In today's class, first thing what we are going to see is, we are going to see first topic, and that is conversion. Conversion of numbers. As already have said you, in the today's class we are going to see the conversion of number system. In that we are going to see how the numbers can be converted. Like if you had octal system, in the octal system how it is going to convert into the decimal system, then in decimal how it is going to convert into hexadecimal system. So we are going to see all these things in today's class. So as we already know that if you had the number systems, like if you had decimal, so decimals are having the base 10. And that what are the numbers we are going to see? We are going to take the numbers from 0 to 9. So 0, how we'll mention that 0 in binary form? 0 can be written as 0, 0, 0, 0. If I am taking 4 inputs. Like that, if I want to write 9, how do I write 9? I can write this 8, 0, 0, 1. That means, what does this indicate? It's 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3. So by taking these all combinations, we can write 0 to 9. That means if I want to write the equivalent number digits of it, I can mention by taking all these zeros. Similarly, if I want to write 9, I can write as 1001. That means that 9 can be written in binary format as 1001. Similarly, next thing what I had is octal system. So octal is what actually it is? 8. 8 means 0 to 7. So that 0 to 7, how do we mention? Since it is 8, only I require 3 inputs. So how do I mention this 0? Only I need 3 zeros. How do I mention 7? I can write 1, 1, 1. Why I am taking only this 3? Because it's 2 power 0 is 1, this is 2 power 1 again is 2, then 2 power 2 is 4. So if I add 4 plus 2 plus 1, I can get as 7. Similarly, if I want to write in hexadecimal, to write the number in hexadecimal, what is the range for it? I do have a range from 0 to 15. So here I required it, since it is 16. 16 means it's 2 power 4. It required 4 inputs. So here what actually 8 means 2 power 3. That means it required 3 inputs. So everywhere whatever the numbers we are taking, it needs to be 3. Similarly, in this, since it is 4, so I need to mention all 4 zeros, then I need to mention all 4 ones. So that's how these systems numbers we have taken. So now in today's class we are going to see how do we convert binary number into hexadecimal number. Let's see the conversion of your number systems with one form into another form. So I'm taking one example over there. I'm taking the binary number that I'm taking, since what I said you, for hexadecimal we need to take 4 sets, like we need to take from range from 0 0 0 to 1 1 1 1. That means each combination should have 4 bits. So for that we are considering over here is 4 bits. In this what we are going to see? We are going to see if I am having the values like, what is the value given over there? 0 1 0 1 1 1 0 1 1 0 0 1. So like this they gave the value. So in that what I am taking? I am combining MSB bit with 4 digits. So what is the first combination it kept over there? It's 0 1 0 1. So I kept 0 1 0 1. Similarly, next combination I have taken the next combination. So what is the first combination I do get? 0 1 0 1. This is the first combination I do have taken. Next would be this combination. Next would be this combination. So what is the first I got? 0 1 0 1. Next I do got 1 1 0 1. Like that I got 1 0 0 1. So I do got this all. So what do I mention for this? How do I mention the place value? It's 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So in this 2 power 2, the 2 power 2 means 4 and 2 power 0 means 1. So 4 plus 1 make it as 5. Similarly, here we do have 2 power 3 means it's 8. 8 plus 4, it's 12. 12 plus 1 it is 13. 13 is nothing but in hexadecimal we mention as D. So because A is 10, B is 11, C is 12, D is 13. So like that, if I do have E, I can mention as 14, F I can mention as 15. So like this, I do have next number 8. Since 2 power 3 is 8, 8 plus 1 I can write as 9. So I can write 5D9 in hexadecimal with the base 16. So likewise, whenever we do have the numbers, when you want to write in hexadecimal, the binary one, we can convert into this format. So similarly, if I had a next example, next what I am taking, the same binary numbers we want to convert into octal. So in that, I am taking an example of next number. In that next number, what I am taking, suppose we do have next example. So instead of hexadecimal, we want to convert into that binary. So binary, we are converting into octal. So octal is range from 0 to 7. It required only 3 bits. That means 0, 0, 0 to maximum 1, 1, 1. So that means whatever the numbers is there, that we need to convert into only 3 bits we need to consider, and we need to convert that numbers into a specific format. So in that, what is the first example I have taken over there? I have taken 101, 111, 100. This is my number in binary format. So I want to convert that binary into octal. So in order to do that, what I am doing, I am combining the starting 3 digits. So what I got first one, 101, I combine next one, I do got 111, like this. I do have next number 100. So what is this? 101 means it's 2 per 0, it's 1, this is 2, this is 4. So 4 plus 1, make it as 5. Similarly, 4 plus 2 plus 1, that is 7. Next is 4. So I can write as 574 in octal. So with the base 8 indicates that binary number has been converted into octal form. Similarly, if I take another example, 1011, suppose this is your example 1. Similarly, I am taking one more example, example 2. In that, what I am taking 1011, 111, 110. So suppose I do have these numbers. So in that, what I am taking, I am combining the starting 3. So what I get, 101 I get. I am combining next 3. What I got, 111 I got. I am combining next 3. I am getting 111. Since this 0 is left, 0 left means we cannot keep as it is. What I have to write? Add 2 more zeros to it. So what I can write for this? This contain 4 digits. So in that, what I am getting? 4 plus 1, it is 5. Then it is 7. Then it is again 7. Then it is 0. So this will be converted into 5770 in base 8. That is called octal system has been converted. So likewise, whatever the numbers is there here, we have to keep in mind that this has to be taken into 3 bits. If you take 3 bits, then only we can get the octal system, because octal should have the combination of 3 bits. The maximum should be starting from 0, minimum is 0 and max is 111. So likewise, if I am having hexadecimal, next we are doing the reverse. Hexadecimal we are converting into binary formats. So let us see the example for it. So what is the number given over there? If it is 5C, this is given. So what is the 5 I can write as? 5 would be 1. If I want to go for the combination of it, like 1, 2, 4, 8, like this. If I am making a table for it, if I want to write 5 as a digit, what is the 5 I can write? 4 plus 1, I can make it as 5. This is 1, this is 1, remaining will be 0. Similarly, if I want to write C, so what is C value I do have? C I can has 12, because A is 10, B is 11. So C is nothing but we should keep in mind that it's 12. 12 how do we mention? 8 plus 4 make it as 12. So it's 1, 1, remaining will be 0, 0. So similarly, I want to combine, this is in 16, that is base 16. I have to write that into base 2. That we need to write. So in order to write that one, what I can write? 0, 1, 0, 1, and this will be followed. So 1, 1, 0, 0. That is in base 2 format. Similarly, likewise, if I do have another number, A, E, 2, F, like this is there, it is in base 16. So we need to convert into base 2. This is another example. I am assuming A, E, 2, F. So A, what actually A value A is 10. So how do I mention A value combination of A? I can write A is 10. 10 how do I mention? 8 plus 2, 10. Here 1, remaining will be 0. Next E. What is the E I can write? I need to mention E value. So E is what? D is 13, E is 14, F is 15. So E. What is E? 14. How do I mention E? 14 means 8 plus 4, 12, 12 plus 2, 14. So 1, 1, 1, 0. Like that I have next F. F I can write 1, 1, 1, 1 since it is 15. So I can write in this format. What is A I had? 1, 0, 1, 0. So I can write 1, 0, 1, 0 for first one E. Next I do have E. E how do I mention E? 1, 1, 1, 0. Likewise I had next 2. So 2 I directly write 0, 0, 1, 0. It's a combination for that 2. 2 means only we want to get 2, remaining all will be 0 only except 2. So I have mentioned over there F would be 1, 1, 1, 1. That is in base 2 format. That's how any hexadecimal number can be converted into binary format. So one of the example I have given over there. Next respective examples at the end of the class I'll give you. You have to try it and get the answer. If you get any queries you can mail me. I'll give my mail ID in comment. Next would be octal to binary. Similarly, if you do have octal numbers are what actually? They gave 4, 3, 6. 4 can be written as, since octal means it's 3 combination, 1, 0, 0. 4 plus 0 plus 0, again 4 only. So in the next we can write the numbers digits in that format. Like this, I'll give one example over here. In that, what I'm showing over here, I'm taking one example, 438 in octal form it is there. I need to convert into binary form of n, binary form of 2. So to do that one, what I'm doing, I want to convert those numbers into binary form. Since octal means it should take only 3 inputs. That means 4 can be written as 1, 0, 0. How it is 1, 0, 0? I'm taking only 3 inputs. 2 power 0, 2 power 1, 2 power 2. So 4 means 2 power 2 means 4. This would be what? 2. This 2 power 0 will be 1. So 4 means 1, 0, 0. What is the first digit I got? I got 1, 0, 0. Similarly, I do have next is 3. So how do I mention 3? 3 would be 2 plus 1, 3. First will be 0. So I can write 0, 1, 1. Similarly, if I do have 8, 8 cannot be considered in octal. So I need to mention some other digits because the range for octal will be 0 to 7. 8 cannot be considered. So for that 7, what I can write? 4 plus 2 plus 1. 1, 1, 1. So I can mention 1, 1, 1. That means our number would be 1, 0, 0, 0, 1, 1. Again 1, 1, 1 in the base 2. So that's how your octal number is being converted into binary form. So depend upon the number of inputs, you can convert your digits. So likewise students, so in today's class what we have seen? We have seen the hexadecimal number. We have taken hexadecimal number, that number we have converted into binary form. So binary should have the base 2, hexadecimal having the base 16. So in this class what we have discussed, whatever the numbers are there, if you want to convert into binary, hexadecimal to binary, we have to combine 4 digits, that is from 0, 0, 0 to 1, 1, 1 max. Similarly, in the next one, what we have seen? We have seen octal system. So octal is having the base 8. 8 means it's have 0, 0, 0 to max is 1, 1, 1 because 0 to 7. 7 means 4 plus 2 plus 1 is 7. That we have converted into binary form. This hexadecimal octal. In the next one, what we need to see? We have to see the decimal also. So in decimal, what is decimal having the base? 10. The value for that would be 0, 0, 0 and maximum is 9. 9 would be written as 1, 0, 0, 1. Here also we need to combine 4 digits. That also we can convert into binary format. So these are the methods we have seen in today's class. So that conversion of number system we have seen. Next would be the number system where actually the number system is going to be used. So in that, what is actually the application of these number systems? So since number system means what? We are giving the information to the computer in order to take the respective information and try to understand in zeros and ones, because the computer can understand either 0 or 1. Further, it cannot take it. If you give some numbers or some alphabet or some information, that would be converted into zeros and ones. So that application part where we will see in flip-flops. So flip-flop is actually a bit of information we want to store it. So that part is called it as flip-flop. So in that flip-flop, what we are seeing one set. Set means it is 1. Another we had reset. Reset means 0. So 1 and 0 if you are giving, it is called it as flip-flop. So what is the use of this flip-flop? It's a flip-flop or latches which we are using in memory elements. So as I already have said you, that part we are going to see in unit 3. That flip-flop, the designing of flip-flop, application of it, where the flip-flop would be used, how it can be used as a memory element, and what are the clock pulse, everything, every topic you will be having in unit 3. So the we just want to see the brief of it. So in that, what we are going to see, we want to connect this to what type of gate it is. It is NAND gate. Why we are saying it's NAND gate? Because we are taking one AND, we are connecting with NOT. So we are giving like this information. We are giving the two inputs like this AB. So we got AB bar over here. Then it is considered to be the NAND gate. So in that NAND gate, we are giving two NAND gates we want to pass and we want to give the output. So this is the application. It is used to get the bit of information, and that is called it as flip-flops. So application of these zeros and ones, one of the application is the flip-flop. So now in further one, we want to proceed with next topic. In the next topic, what is there? The Boolean algebra we do have. That Boolean algebra, the function of it, then application of it, where actually this Boolean algebra can be used, that complete part we need to see in detail. So before proceeding with this thing, I'll give a small problems as an assignment, or you can consider as a homework, and you need to do it. So in that, I'll give some questions. That questions you need to convert those numbers into binary one and the vice versa. So like this, I'll give first thing convert into binary. First problem is for, by seeing the question you have to do with respect to that specific number system. Suppose I do have 16AF. That is in, since it is AF, that means it is in 16. So we have to convert that number n I am mentioning into base 2. Next number, second part. In second one, next one, so 2AF 0. That 16 we want to convert again into n format with base 2. Third, next I do have 2, 3 and 7. For example, in base 8. 8 means it is octal. So that we need to convert into base 2. So likewise, next number, if I do have 1, 7, 3. That is in octal form. That also we need to convert into the binary form. So why I am mentioning this? 8 means it's octal, 16 means it's a hexadecimal. So that numbers we need to write in binary form. So one more example I'll explain over here so that this will become easy. Suppose instead of this, if I do have numbers like A, 2, 1, 0 in 16. So we need to write that into base 2 format. So what is A means? A is 10. So 4 inputs 10, how to mention 10? 10 value you need to write is 8 plus 2, 10. How I am mentioning 1, 0, 1, 0? Because it's 2 power 0, 1. This is 2 power 1, it is 2. This is 2 power 3, 2 power 2, it is 4. This is 2 power 3, it is 8. That means 8 plus 2 is 10. 10 means A. So since A is 10, right? Next I need to write as 2. So how do I write 2? I don't want all this, only I want this 2. That means these all zeros, only 2 should be there. 0, 0, 2 only means 1, 0. So that is the equivalent of binary digits. Next, likewise, we can convert 1. So 1 means only I have to get 1. This I don't want. So what I'll write? 0, 0, 0, 1. Likewise, last digit, this 0. 0 means, since we are all are taking what, how many combinations? 4, 4, and over here is also 4. So last, all 4 zeros you need to mention. So that is the complete in base 2. So that is the one of the example that I have shown over here, so as to convert that hexadecimal into the binary form. So this just like an example problem you can consider, and you need to solve based upon that. If it is octal, only 3 bits. Like if you want to write 1, 1 would be 0, 0, 1. 7 will be 1, 1, 1. 4 plus 2 plus 1 is 7. Like this 3. 3 we can write 0, 1, 1. Like this it will convert into the binary form. So likewise, you need to solve these all 4 and convert those into binary form. So this is how this number systems is going to be converted into binary form. In next class, we are going to see this complete part, like introduction of Boolean algebra. Boolean algebra over here is, we want to use some Boolean functions. Boolean theorems are there just in conversion of zeros and ones only, but the specific Boolean theorem is given by a specific person, that by using those theorems we want to convert into Boolean algebra. So how it is started, that history part also we want to see. Then logical operators. What is the logical operators? We have seen NOT, OR gate, AND gate. These are the basic logical operators we will be having. Next will be that Boolean theorems and its properties. That Boolean functions, how it is be using, what are the theorems are there. That one we want to verify. Next would be Boolean functions. By using the Boolean function, we will be having 2 terms, mean term and max terms. By using mean terms and max terms, we had the set of numbers that we want to convert into the respective numbers. So likewise, we will be having canonical and standard forms, and next would be having digital logic gates. That is, just we have seen the basics that applied, how we do get the hardware designing by using the logic gates. So that all we will see in the next class. So thank you for today's class. Prepare these questions as a homework.